Good afternoon, everyone. We are from Group 4 and we are going to present to you how condensed milk was being processed. So, condensed milk is one of the most concentrated form of milk, thick in consistency and having high nutritional value. It is widely used in several forms in our daily diet. Taking condensed milk can boost calorie content, which may be more beneficial than using sugar alone. Condensed milk are the products obtained by evaporating a part of water of whole minor fully or partly skimmed milk with or without the addition of sugar. So water was removed roughly for about 60% of it. The main objectives of manufacturing condensed milk are we have preservation of milk, reduction in bulk for the purpose of long-distance transport. So, the term condensed milk is commonly used when referring to full cream sweetened condensed milk, whereas the form evaporated milk is commonly used when referring to full cream unsweetened condensed milk. So, we have two types of condensed milk. We have unsweetened condensed milk and sweetened condensed milk. So, for unsweetened condensed milk, it's also said to be as evaporated milk. This is the product obtained from cow or buffalo milk or a combination thereof by the partial removal of water. It may contain added calcium, chloride, citric acid, sodium citrate. Sodium unsweetened condensed milk should contain not less than 8% milk fat and not less than 26% milk solids. And for sweetened condensed milk, it's a product obtained from cow or buffalo milk or combination thereof with the partial removal of water after addition of canned sugar. Sweetened condensed milk should contain not less than 9% milk fat and not less than 31% total milk solids and not less than 40% cane sugar. It is available in flavored as well as unflavored type in the market. So, sweetened condensed milk has gained popularity in numerous dessert dishes. So, these are the uses of condensed milk. We have sweet milk drinks in tea or coffee, ice cream preparation, bakeries and confectionery, and milk chocolate. So, condensed milk is very helpful as substitute for sugar, especially in adding sweets to the recipes. Especially in cakes when you're baking, condensed milk lends moisture, tenderness, and flavor to the recipe as well as the color to the crust. And condensed milk is also healthy since it provides extra protein, fat, and some bone-healthy minerals. These are the basic raw materials requirement in making condensed milk. We have milk, sugar, and preservatives. Here are some equipments and machinery. We have milk storage tass. The milk storage tass is ideal for cooling and holding milk out at cold temperature until it further processed. Next is milk evaporator. Evaporated milk is made by removing water from fresh milk and then heating it. Heating the milk gives it the creamy, slightly cooked taste and darker color. Then, when mixed with an equal amount of water, it can be substituted for fresh milk in recipes. Next is homogenizer. Homogenizer, which is perfect for dairy processing needs. And then boiler. Boiler is the dairy industries mainly perform the process of milk pasteurization and ultra heat temperature, which is UHT, to ensure that the milk is safe for consumption and free from harmful bacteria for optimal shelf life. So next is refrigerator. By refrigerating, it keeps the milk cold and stops the bacteria altogether, and the milk can last for months. And next is can washer. Can washer removes oil, lubricants, and metal fibers coming from the body of making process and makes the can fit to be decorated. And lastly, we have milk filling machine. Milk filling machine used for packaging, mainly for food or beverages, but for other products as well. So this is the automatic process line for condensed milk. First is evaporation, and then homogenization, then cooling, intermediate tank, canning, sterilization, storage, UHT treatment, and then aseptic filling.
Good afternoon, everyone. So here is the sample process flow diagram of a condensed milk. So from receiving of milk to preheating and standardization, then the addition of sugar to heat treatment, evaporation, homogenization, cooling, and crystallization. And lastly, the packing, inspection, and storage. So here's the sample video clip of condensed milk manufacturing. So here is the first step of condensed milk manufacturing, the receiving of milk. Raw milk received for the manufacture of condensed milk should be a good quality. This is important because the quality and the marketability of a final product depends upon the initial quality of a raw milk. So when the milk is received, the temperature should be about 10 degrees Celsius or below. As far as possible, milk should be fresh, sweet, free from odors, and free from extraneous matter. The acid development of milk is considered objectionably, for not only does this indicate an excessive bacterial count, but it also reduces the heat stability of the milk. So the next step is the filtration and clarification or preheating. Milk should be clarified and filtered to remove visible foreign matter. Milk is generally preheated to 35 to 40 degrees Celsius to increase the efficiency of the operation. It should be cooled to preserve its quality. Simple filtration may remove suspended particles by straining process, while the clarification removes the same by centrifugal sedimentation. So the next step is the standardization of milk. It refers to the adjustment of milk, which means rising or lowering of fat and solids non-fat levels of milk. It is commonly done in case of a market milk supply and also in case of a manufacture of milk products. So the figures vary with the applicable standard but are normally 8% fat and 18% solids non-fat. The ratio of fats to solid non-fat is consequently 8:18 or 1:2.25. The stipulated percentages are minimum values which must be maintained, but for reasons of economy, they should not be exceeded by more than a reasonable margin. So the next step is the addition of sugar. It is a key step in the manufacture of sweetened condensed milk. It is important that the correct proportion is added, as the shelf life of the milk depends on its osmotic pressure being sufficiently high. The quantity of sugar added to milk should be enough to preserve the milk. The sugar is pasteurized along with the milk. However, this procedure causes fairly extensive Maillard reactions during heating and evaporation, and above all, a faster age thickening. A concentrated sugar solution, which should be sufficiently heat-treated to kill any osmophilic yeast. It is recommended that sugar ratio of 62.5% would protect the condensed milk from the bacterial effects. So the next step is the heat treatment. The standardized milk undergoes heat treatment before being sterilized to destroy microorganisms and to improve its coagulation stability. A part of the whey proteins is denatured during heat treatment while the calcium salts are precipitated. Heat treatment will determine the viscosity of the end product, and it thus extremely important to the quality of our product. So the next step is the evaporization of unsweetened condensed milk. It is the removal part of water from milk by boiling it under low pressure. It is the process takes place at a maximum temperature of about 70 degrees Celsius. Heating milk gives it the creamy, slightly cooked taste and a darker color. The evaporization is usually in the multi-stage falling film type. The milk passes through steam-heated tubes under vacuum, so the dry matter content of the milk increases as the water boiled off. The density is checked continuously. So the next step is the evaporization of sweetened condensed milk. It is carried out in essentially the same way as for unsweetened. When sugar is added in the evaporator, the syrup is drawn into the evaporator and mixed with the milk at the halfway stage of the process. Continue to process until the required dry matter content has been reached. The dry matter content is checked indirectly by determining the density of the concentrate. So the next step is the homogenization. It disperses the fat and prevents the fat globules from coalescing during subsequent sterilization. Two-stage homogenization is recommended. Homogenization should not be too intensive because that might impair the stability of the protein with the consequent risk of the milk coagulating during sterilization. It is necessary to find the right homogenization pressure that is high enough to produce the required fat dispersion, yet low enough to eliminate the risk of coagulation. So the next step is the cooling. Cooling of condensed milk is essential to control its texture. It should be cooled in the right temperature because in this process it helps to prevent the formation of large lactose crystals. A final check of the fat content in the solid non-fat is usually made at this stage. The quantity of phosphate to be added is determined by sample sterilization, and any addition of vitamins is also done at this stage. So the next step is the crystallization. The purpose of this process is to produce mass crystallization of lactose. It is a period in the cooling process when sweetened condensed milk reaches a temperature which is most favorable for rapid crystallization of lactose. For sweetened condensed milk of average composition, the temperature of maximum rapidity of crystallization is around 30 degrees Celsius. The lactose in solution can only be held and half the amount of water and condensed milk. As a result, the remaining half will precipitate in the form of crystals. If enough lactose is allowed to precipitate freely, large sugar crystals will form. It makes the product gritty and unsuitable for many applications. It is better to control the crystallization of lactose in order to achieve very small crystals. The required crystallization is achieved by rapidly chilling or cooling the mixture while rapidly agitating it without trapping any air.
Canning is one of the processes of condensed milk. Canning machines for condensed milk automatically fill and seal the cans before sterilization. In canning process, it is a one way of preserving and saving the energy at the same time. This is also the reason why condensed milk in a can has a long shelf life because of the metal can food packaging that helps to prevent food spoilage. Sterilization. The filled and sealed cans pass from machines to autoclave, which can operate either continuously or the batch principles. In the sterilization process, the extensive heat treatment is used for evaporated milk, whereas Sweetened condensed milk is preserved by the addition of sugar and the reduction of water activity that ranges to 0.78 to 0.82. Storage and inspection process. The cans or aseptic paperboard packages of condensed milk are labeled before being packed in a cardboard cartons. Condensed milk should be light in color and have the appearance of cream. Several sample cans shall be taken from each production batch for inspection. As a consumer of condensed milk, it is really much important to remember, as long as the can of condensed milk is unopened, place it in a cool and a dry place area that is away from any heat sources. Once you open it up, transfer the leftovers to other containers and refrigerate it. So in conclusion, the innovation in condensed milk is a major factor contributing to the global growth in the market. Furthermore, condensed milk is one of the major ingredients in desserts such as cakes and ice creams, owing to its thick texture and sweet taste. One of the major attributes of condensed milk, which is anticipated to drive the market, are the quality and the shelf life, in which the major preference factors of consumers. The product lasts for at least a year beyond the printed expiration date if unpacked, and for approximately 3 weeks after it has been opened. The metal can packaging helps to have a healthy inner coatings to prevent food spoilage from chemical reaction. Moreover, these cans are sealed pack, which prevents food spoilage during transport. These are the major factors anticipated to increase the product demand in the coming years. There are innovative packaging that we are usually seeing in the market, such as bottles, tubes, pouches, sachets, Tetra Paks, bag-in-box, and glass containers. This is expected to improve product demand, thereby driving the sweetened condensed milk in the future.